Hello there, Mustangs. Thanks for coming back for another edition of How to Do Stuff. Rosenwald here, and I think I'm going to start you guys off with a joke today. Who doesn't like a good laugh in the morning? So here's the joke. Why did the Scarecrow win an award? Because he was outstanding in his field. That's good stuff right there, right? Okay, anyways, let's go ahead and get started here. So for this lesson, what we're going to be working on is negative exponents. To do a real quick review, just to throw in some algebra review here, when we're doing x is equal to 3, what that means is we're going to go ahead and evaluate by taking each one of these x's and replacing it with that 3 that's there. And so when we do that substitution, we're going to have a parentheses squared plus 10 times parentheses minus 4. And remember that every time we substitute, we're always going to put in parentheses with that value. So let's go ahead and simplify this. 3 squared is, remember, 3 times 3, which is 9. 10 times 3 is 30, minus 4. And then remember, we just go from left to right when we're doing the orders of operation here. So this will be 39 minus 4, which means our final answer is going to be 35. Okay? All right, so moving negative exponents. If you remember from our lesson, what we talked about, or in class, what we said was you got happy people and sad people. Happy people always want to switch classes, so they're going to move from one classroom to the other classroom. And if they're happy, they're going to stay exactly where they are. But that's only when we're talking about stuff that has exponents, okay? So one thing at a time here, let's look at each of these. We've got a 5, we've got an x to the negative 3, and we've got a y to the negative 7. There's 3 separate things going on here. Now, only the stuff with exponents are going to switch places. So when we look at this first one here, that 5, that doesn't have an exponent. That's going to stay exactly where it is. That x to the negative 3 is not happy, okay? And because he's not happy, he's going to move. So instead of him staying in the top here as an x to the negative 3, what we do is we're going to take him and move him to the other classroom, and because he moves, he becomes happy and he loses that negative that he had. Okay? When we look at the last one here, the y to the negative 7, that y to the negative 7, when we look at it, is not happy. So again, we're going to take it and move it to the other classroom, and when it moves, it's going to become happy. That's it. There's nothing else to simplify here, so we're done with that problem. Okay? Take a look at number 2. All right, we're going to go ahead and draw in our line. And let's start off by first highlighting each one of these. So we've got a negative 6. We've got a negative a to the negative 3. We got a b to the 7th. And we got c to the negative 1. Okay? That negative 6, when we look at it, the negative 6 is not an exponent. It's a number. So remember, that does not move. The a to the negative 3, let's go ahead and write that out. What's going to happen is because it's negative, it's going to move, and when it moves, it's going to become a positive. Okay? The b to the 7, we're going to write that in there. It's happy. It doesn't have a negative, and because it's happy, it's not going to move. It's going to stay exactly as it is. Okay? The c to the negative 1, when we look at that, is not happy, and because it's not happy, we're going to move it, and when we move it, it's going to become happy. And it's going to stay exactly where it is. No colors match up with anything, so we're done, and we don't have to simplify. We're done. Okay? Take a look at number 3. All right. In number 3 here, we've got a negative 12. Sorry, I wanted to highlight these first. We've got a negative 12. We have an x to the negative 6, and we've got a y to the negative 2. So little part by part here. Ready? I got to stop doing that. The first thing I always do is do the highlighted blue. The negative 12... it's not an exponent. Just because it's negative doesn't mean anything. It doesn't move. Okay? It's only if it's an exponent that's going to move. The x to the negative 6, when we look at it, that x to the negative 6, since it's got a negative exponent, it's not happy, we're going to take it and we're going to go ahead and move it. And when we move it, it's going to become happy and it's going to stay there. The y to the negative 2, which is currently on the bottom, we're going to look at that and go, all right, well, he's not happy down there, so we're going to take him, we're going to move him to the other class, and when he moves to the other class, he's going to become happy. And that's it. We're done. All right. Number 4. Let's highlight each section here. So we got a 21. I'm going to highlight the 15 because those are the same thing. They don't have variables. I'm sorry, they don't have exponents, they don't have variables, they're just the coefficients, okay? The a's, I'm going to go ahead and write those in the same colors because what happens is those a's are going to join up, whether they're on the top, the bottom, or they're going to cancel each other out. Regardless, like they're going to be the same letter, okay? And my b's, I'm going to do in the same color because they're the same letter. All right, so let's go ahead and start first by going with the blues. So 21 over 15, okay? That's a fraction. When we put this into our calculator, we can reduce it. You guys should know how to use decimals at this point. If we divide by 3, we're going to get 7 over 5 for the reduced fraction there. Okay, so that's again divided by 3, divided by 3, we're going to get 7 over 5. For our a's, let's start with first a to the negative 5. It's not happy. And because it's not happy, it's going to go ahead and move down to the bottom, and when it moves, it's going to become happy. Okay, the a to the 7 that we had down there is already happy, so we're not going to move it. Now when we look at the bottom there, we look at those a's, there's 5 a's right here and there's 7 more right here. So remember, when we're multiplying these, we add them together, 5 plus 7. So that means we're going to have 12 a's on the bottom. For the b's that are going on there, we have b to the 10th power. When we look at that, that's already happy. Oh, I'm in the way as always. All right, when we look at the b, I'm going to put myself over here. When we look at the b's, there's 10 b's right there. It's positive, meaning that they're happy. They're not going to move, okay? Let's look at the b to the negative 3. Well, because it's a negative 3, they are not happy, so they are going to move. And when they move, they're going to move up to the top. And when they move, they become good, happy. And when we look at those b's, there's 10 here and there's 3 here, so there's a total of 10 plus 3 when we're putting those together, which means we're going to have b to the 13th power. And you are done. Okay? All right, let's take a look at number 5. Okay, we're going to go ahead and take and distribute, because we've got an exponent on the outside, that negative 3 is going to be distributed to everything that's inside of here. Okay, so that's going to be our first step here before we do anything. So take that negative 3 and distribute it. We're going to have 4, and that's going to be raised to the negative 3. We're going to have x the second, and that's going to be raised to the negative 3. And then we're going to have m to the negative 4 raised to the negative 3. Okay? From here, we're going to go ahead and do the distribution that's necessary. I'm not going to move anything yet. Okay, we don't want to move anything yet. We always want to get things taken care of first by distributing. I didn't put the 3 there. Whoops. And then what's going to happen, the reason we do this is actually it's because of right here. What's going to happen is when we have a power raised to a power, if you recall, we take these powers and we're going to multiply those together. That negative 4 times negative 3 is going to equal 12. So this is why we don't move anything right away, because the negative times the negative equals a positive. That means that because I have a positive, I'm not going to end up moving this at all. So sometimes those negatives will actually cancel themselves out. But now that we're done doing the distribution, let's go ahead and put each part where they belong. Okay? So 4 to the negative 3. Now that's a negative exponent. Watch what's going to happen here. That 4 to the negative 3, because it's a negative exponent, is going to move. And it moves down to the bottom. And it's going to become a positive 3 right there. Okay? The x to the negative 6 right here, x to the negative 6 right here, is going to be a negative exponent, not happy, that's going to move. And because of this, it's going to go ahead and turn into a positive down on the bottom there. And then the last one here, the m to the 12th, because it's a positive exponent, it will not move. Okay? So we've done all the movements. Now let's just see if there's any simplifying that we can do. That 4 to the 3rd power we can put in our calculator, and that's going to give us a 64. It's not 12. Remember, this is 4 times 4 times 4, which is 64. Okay? The x to the 6th won't change, and the m to the 12th will not change. So this will be our final answer here. Okay? A couple more here. Number 6, we have no distribution because there's no power raised to a power. So let's go ahead and just start setting up each problem and simplify each one of these parts. So the 28 and the 30 is going to be its own thing. The p's will be its own thing, and the m's will be their own thing. So we got 28. I did it again. 28 over 30. Can that reduce? If we throw that into our calculator here, 28 divided by 30, I can divide each of these by 2. And we're going to get 14 over 15. All right. For the p's, we have p to the negative 5. That negative exponent is not happy, so it's going to move down to the bottom, and it's going to become positive. Okay. The p to the 7th that we've got there, that's a positive exponent, so that's not going to change. Sorry, I meant to actually be doing this up on the top here, so let me do this again. That p to the 5th was right there. The p to the 7th was right here. So when we put these together now, these p's, there's 5 and 7, we add those. So that means we're going to have p to the 12th. Okay. For the green, we're going to have m to the negative 10. Because it's a negative exponent, it goes ahead and moves, and then it becomes a positive. And the m to the negative 3 that was there, it's going to go ahead and move, and it's going to become a positive on the top. Now, this is our first time seeing this one in this notes. When we look at the m's, there's that battle going on, the north versus the south, numerator versus denominator. And so what's going to happen is we have to ask which one has more. The top one only has 3, the bottom one has 10. Which one has more? Well, clearly it's the bottom. So they're going to fight each other and eliminate each other, which means we're going to have 10 take away 3. And because the bottom has more, there's going to be 7 remaining on the bottom. And this will be our final answer. All right, take a look at number 7. There's no distribution here because of the fact that there's no exponents in the tops of these parentheses. So there's no distribution. So we could just start diving right into our problem here, okay? Let's go ahead and put stuff together first. Okay, so when we do that, we're going to have negative 10 and 3 will get multiplied together, and that's going to turn into a negative 30. Okay, let's move to the next part, which is a to the negative 5 and a to the second. So the a to the negative 5, let's put that in there. What's going to happen is because that's a negative exponent, that's going to move. And when it moves, it becomes a positive. Whoops. Okay, so it becomes a positive. The a to the second, when we put it in there, because it's a positive, that won't move. And so what's going to end up happening is we're going to end up having a battle between these two. Well, who wins the battle? The bottom has more, so remember it's going to be 5 minus 2, which means we're going to have 3 a's remaining on the bottom. Okay. Let's look at our b's. We have b10 and b negative 12. So for the b10, it's a positive exponent. It won't move. And for the b negative 12, that's a negative exponent. It's not happy, so that's going to move. And when it moves, it's going to become a positive. Okay. And now we don't have a battle going on. Instead, we're joining forces. We're becoming stronger. So what's going to happen is we're going to become 10 plus 12, which means we're going to have 22 B's. Okay? All right, we got one more here. This one's going to have everything kind of combined. So when we look at this one, it's actually got that negative 3 going on there that's going to be distributed. Okay? That negative 3 is going to be distributed to everything that's inside the parentheses. Notice that this 4 that's down here, that's on the bottom, that's not actually in the parentheses, so that's not going to be included. Okay? So what will this look like? Well, we're going to have a negative 5. We're going to have an a to the negative 4, and we're going to have a b to the negative 3. And remember I said, don't move stuff yet. The exponents will sometimes cancel themselves out, making our lives really easy here. Okay? And then we got that 4 on the bottom. So let's continue here. We're going to have a negative 5 to the negative 3. When we multiply these exponents together, we're going to get a to the 12th power. And then multiply these together, we're going to get b to the 9th power. And then a 4. So when you look at this, look at what happened here. All of my negative exponents that we had canceled themselves out, except for that one that's right in the front here, that -5 to -3. That's the only one that didn't cancel. So that means everything else stays exactly where it is. So that A12 will stay where it is. The B9 is going to stay where it is. But what's going to happen is this negative exponent that we have right here, that -5 to -3, it's going to move down to the bottom. And it's going to become a positive exponent. So you could throw this into your calculator, and what you're going to get is a -125. And that's going to be multiplied by 4. So that means what we're going to end up with is a -500, I believe. That is it. That concludes this pretty easy stuff, in my opinion. It's just an extension of what we've been doing. But notice how we try to do it step by step. That's how you get through these problems. Don't try to look at it as one big problem. It's just a bunch of little problems, okay? I trust that you can do this. I believe in you. You take care and have a wonderful day until we see you next time. And don't forget to like and subscribe. Don't forget to do it, okay? Thank you.